doing quadratic functions, and we're dealing with the minimum and the maximum value and the sketching of the graphs. So this is what I was just illustrating here. Say when we talk about the minimum or the maximum, we're talking about the turning points, meaning these are the points at which the curves are turning. Yeah, at which the curves are turning. It can either be the minimum or the maximum value. Yeah. So this is what we're talking about. Yeah. So by completing the square method, by using the completing the square method, when you complete the square of this given function here, you discover to say what you are going to have is this at the end. So when you complete the square of this expression here, which is this part here, you find this as your other part, meaning your other solution. So once you find this, you have to take to do what? You have to know to say this part here, when you equate it to 0, is the one that will give you the value of x at this point or at that point. And this is also called the line of symmetry. So when you say x, when you equate x, rather, let me just write this. When you write x is equal to, or x plus, let me just copy what is in the brackets there, x plus b over 2a is equal to 0. So you're going to have x being equal to the negative of b over 2a. So this one is called the line of symmetry, or it's just the value of x at which the curve is turning, or at the turning point. And then the value of y at the turning point is just this part here. Yeah, so this part is the one that is even called the maximum or the minimum value. So if you want, you can master this, or if you don't want to master this, you can just know this part, and then once you find this part, you find the f of this part to find this other part. You're going to understand what I'm talking about when we begin doing some examples. So this is what I was saying. The value of x at the turning point is given by negative b over 2a. And then it's also called the line of symmetry. So the minimum, rather the minimum or the maximum value of y at the turning point y is equal to f of negative b over 2a. So let's try to look at this example here, which is our example 1. Yeah, the question is saying complete the square of each of the following quadratic functions. Hence, sketch the graph of the function showing clearly the x and the y intercepts and the turning point. So the first question here is saying we first find the line of symmetry. Remember what I said, when you complete the square of this, the line of symmetry is just given by this. Now, since we've been told the method to use, if we were not told the method to use, we would have just gone directly to use this part here. Now, since we've been told to use, to use completing the square method, it simply means that we are going to complete the square of this equation here. So what I'm trying to say is we write 2 like that, then you write 2, and then you open the square brackets, then you open this parentheses. So you're going to, when you factor out 2 from these two first terms there, you're going to have this. Actually, this was even part of your exercise. This question was part of your exercise. The previous exercise I gave you, most of you failed to what? To complete the square of this question. So this is what we're going to have. So you're going to have minus. So when you factor out 2 there, it simply implies that you are dividing everything by 2. So you are going to have something like this. So the next step here would now just be to, so you find half of this negative 2. What is half of that negative 2? So half of negative 2 is simply, so half of negative 2 is just negative 1. And then this, you square it. Then you say minus the same thing again. You square it like that. So you can put another bracket there and then close, then plus 5. So write your 2 like that, open brackets. So you're going to have x minus 1, then you have squared like that. So this will give you, when you square this, you give you positive 1. So you're going to have something like this, plus 5. So when you open the brackets there, you're going to have 2 and then open brackets x minus 1, and then squared this side, minus 2 times 1, negative 1 there, you get 2 there, and then you have your plus 5 there. So this, from this you're going to have something like this. So negative 2 plus 5, you get positive 3. Yeah, so this is, so when you reach this part, it means that you have finished completing the square. So now, how do you, I've forgotten to write a squared here. So now, how do you determine the line of symmetry, the maximum and the minimum value? So the line of symmetry, like I earlier on said, you just equate what is in the brackets here. You equate what is in the brackets here to 0. So to find the line of symmetry, I'm just going to say x minus 1 is equal to 0. Then you say x is equal to positive 1 like that. And then to find the minimum or the maximum value, and in this case we're finding the minimum value because the value of a here is positive, it's greater than 0. So meaning since a is greater than 0, we are simply finding the what? The minimum value. So the minimum value, is just equal to this number here. Remember what I said? It's just this number, which is equal to 3. Yeah, so the turning point of this curve, if this was to be a curve, the turning point would be given by, so the turning point is just this 1, that is the value of x at the turning point, comma this 3 this side. This is our turning point. Yeah, so if we were to sketch this curve, we also have to find the y-intercept and the x-intercept. The y-intercept, we know that in the y-axis, the value of x is equal to 0. So what you do is, in the, okay, let me just end here. We'll look at the next question. Okay, so this is how you find the minimum value and the line of symmetry. Example 2, complete the square of the following quadratic equations given below, hence find the turning point and the x and the y intercepts. So when you complete the square, of that equation there, you agree with me that you come to a point where you are going to have something like this. Yeah, since this meeting can end in just a few minutes time, because we I had a network cut at some point, you remember. So I'll try to skip some of the steps here. Let me just write the final answer which has been completed. So we have a little bit, we have some more questions that we need to solve here. So let me skip just steps here. So when you complete the square of this expression there, you have something like this. Okay, you have something like this. Yeah. So this is what you're going to have after completing the square. To find the turning point and the x and the y intercepts, so the turning point first of all would be given, would be given by, when you get this x to 0, this x plus 3 to 0, we discover that your value of x will just be equal to -3. So the turning point would be -3, comma, this 10 this side, -3, comma, this 10. So this is the turning point. To find the x-intercept, so to find the x-intercept, we know to say that in the x-axis, the value of y is equal to 0, or rather the value of f of x is equal to 0 in the x-axis, meaning where there is f of x or where there is y, you put 0. So when you put 0 this side, it means that you're just going to take this 10 to the other side of the equal sign, meaning you have something like this. And you are going to have something like this. Yeah. Then when you find the square root of both sides there, and then you make x the subject, you have something like this: -3 plus or minus the root of 10. So meaning we have two values here. We have -3 minus root 10 and -3 plus root 10. These are the two values of x that we have. So meaning this curve is meeting the x-axis at 2 points. Now let us find the point at which the curve is meeting the y-axis. How do you find that? We know to say in the y-axis the value of x is equal to 0. So meaning where there is x in this expression, or where there is x in this expression there, you put 0. So when you put 0 here, 6 times 0 is 0. X, when you put 0 there where there is x, 0 squared is still 0. So meaning the value of y, rather the y-intercept, is just equal to 1. When you put 0 where there is x there, you just remain with this one there. So this is the y-intercept. We know to say in the y-intercept, or in the y-axis, so in the y-axis, the value of x is equal to 0. That is in the y-axis. Okay. So now we move on to sketching the curve. So sketching the curve, as usual, you write your x or y plane like that. So where is our turning point? Our turning point is at -3. So I'll put -3 somewhere there, comma 10. And I'll put my 10 somewhere there. So which is that point. So if I'm to, yeah, so I'm going to have something like this. So this is my turning point, and then I'll sketch something like that, which passes through, is meeting the x-axis at 2 points. So this point, this first point this point, first point here is negative 3 minus the root of 10. Then this other point is negative 3 plus the root of 10. And then this turning point is negative 3 comma 10. Yeah. And then you also don't forget to add the axis of symmetry. You just label it to say this is x is equal to negative 3. Yes. So this is all about sketching. This is how you sketch the graphs of quadratic functions. So now imagine if this was in absolute value symbols. So if this was like this, if this had absolute values outside like that, it means that it will not pass through the what? I mean, it will not come to the negatives this side. It will just let me show you how it will look. It's going to be just like this. It's going to come like that. Instead of proceeding to the negatives, it will bounce to go like that. Same applies to this part, like that. Then to bounce, go like that. Here, of course, you can do some sketching if you want. Yeah. So this is how it will look. Yeah. So this is what happens when it has absolute values outside. It will just bounce. It will just be on the positives. It will not proceed to the negatives. Okay. So let us try to see this question here. Saying find the set of values of x for which this is equal to that. So here I've just taken you back a little bit. We skipped this part. So I just thought of getting one question which we can solve together, but I'll just show you how to solve it and you'll finish it up. It's simple. So when you have such a question, you first take this part, you solve it separately. Like this. You also take this other part, this one this side, you solve it also separately. So meaning you have something like this. Like this. So now you solve this part separately, you also solve this part separately. But of course, this one, just by looking, you can see that it's giving you 0. 0 is less than 0. So I think this one is will come out automatically. Now, when you solve this part, the answers that you are going to find, the answer that you are going to find is the actual answer for x. I think you find some, just by looking at it, you can, I think you find something like this. Yeah. Yeah, I think something like this. 0 is greater than, or I mean, 0 is less than or equal to x. Yeah, I think something like this. You can try to solve it on your own. So when you have been given such a question where you have two signs like this, two symbols like that, you first deal with the first part, you solve it, and then secondly, you come and solve the second part. Then the values of x that you find, the first and the second part, you combine them together. Yeah. All right, let us now look at, I think, the last question for today. I thought of adding this question because it's very important. Most people find challenges solving such questions. So this question here is saying, find the set of values of x for which for each of the following inequalities, which is the first one is this one. So what you do first is you just copy this question. When you copy it, instead of putting less than or greater than or whatever symbol that you've been given there, you just put a 0 there. Then solve it normally, the way we solve other questions. So here you first find the sum. The sum is -4, the product is -5. So here the factors that you are going to have are, I think it's +1 and -5. So you have something like this, plus x minus 5x minus 5 is equal to 0. So here, having written this, you can factorize now. So meaning when you factor out the x there, you're going to have x plus 1. Then here you factor out -5, you also have x plus 1 this side, being equal to 0. So x plus 1 is common, you write it like that. Then x minus 5, you also write it that side, being equal to 0. So you find what are called you first find the 2 points of x, the two values of x. So you equate x plus 1 to 0. You also equate x minus 5 to 0. So here the value of x is equal to -1. Then the value of x here is equal to +5. So these two values of x that we have found are called the critical points. So these critical points are the ones that you are going to use to find the range of values of x, rather the set of values of x that are needed for this equation or to satisfy this quadratic inequality. So how do you now find the ranges? So you can draw your number line like that, and then put in your critical points. So you have our critical points, -1, then you have 5 there. So here we know to say these numbers are x is less than -1. Then here we know to say it's between -1, our x is between -1 and 5. Then this side, the value of x is greater than 5. All right. So from here now we begin to test our points, taking this part here. So when testing, we get this part, which is x plus 1, and then x minus 5. Then we will now replace that equal sign with that symbol there. So we see which one is going to give us the true, or which is going to be true. This is going to be the true condition here that is needed. So when we get any number that is less than -1, we get maybe -2. When we put -2 this here, -2 plus 1, we get a negative number, which is a -1. And then -2 minus 5. -2 minus 5, we get -7, still negative there. Then negative times negative is positive to give us positive. So now you can try to see, is a positive number less than 0? Of course no. So this part cancelled. We get any number between there. Between -1 and 5, we can get 0 there. When we put 0 there, x, which is 0 plus 1, will get 0 plus 1 will get +1. So I'll just write a positive there, multiplied by 0 minus 5, you get negative. 0 minus 5, you get negative 5, so you just write a negative there. So positive times negative there, you get a a negative, sorry. So we get a negative answer. So is a negative less than 0? Yes, so this part qualifies. We go to the last part there. You put a positive, you get any number greater than 5. Yeah, so we put a positive 6 there. 6 plus 1, you get a positive number. 6 minus 5, you still get a positive number. Positive times positive, you get a positive number. So is a positive number less than 0? This part also refuses. So our values of x, or the set of values of x, is just this part here, the middle part. So it can either be written in set builder notation or in set form. So you say x is equal to, you write your negative 1. Since this less than symbol here has no equal, it's not less or equal to, so meaning the bracket that we are going to use here is this, and then comma 5. You also use that. If you want, you can use the set builder notation where you say x is such that x is a member of real numbers, where negative 1 is less than x less than 5. Yeah, so this is the right way of representing this. So in other words, this is the solution for this question. All right, so you guys have prepared an exercise for you. It's just unfortunate that some people are not able to submit their exercises. Only a few, and same individuals are submitting their exercises. I've not been seeing you. Some of you, I've never even seen your handwriting. Yeah. So please make sure that whenever I give you the exercise, you write and submit, so that I see whether you are understanding or not. So you're going to sketch. You're going to have this question here that you're going to sketch. You complete the square, and then apart from doing that, you sketch the graph. Yeah. So even here, question 3 is saying find the set of values of x for which this is less than 8. So now here it's just a matter of solving this inequality, which has absolute values symbols. Yeah, when you solve it, you find the values of x. Now, of course, there's this symbol there. It means that the final answer is supposed to be a range. You're dealing with real numbers. Same applies to this part here. You're dealing with real numbers, so meaning your final answer is supposed to be a range. Yeah. Thank you very much for watching today's lesson. See you in the next lesson. So on Monday, we're starting a new topic. On Tuesday, we're starting a new topic. On Monday, we're just going to finish functions. But the subtopic of these functions, we're going to be doing polynomials. So make sure that you don't miss. There are a lot of things that you need to know about polynomials. There are a lot of them. Make sure you don't miss out what we're going to be discussing on Monday. Yeah, but yeah, just make sure that you don't miss, because you need to know how to divide polynomials, how to find the factors using trial error method. Okay, you need to know a lot about polynomials. Yeah, so just make sure that you don't miss. Yeah, and for those of you who have not yet subscribed to the channel, make sure that you subscribe. Yeah, because there's some questions that individuals ask. Sometimes if I see that it's a very important question, I'll just make a tutorial video and post it direct on YouTube. It may help one of you, or it may help you. Yeah. So make sure that you subscribe and turn on the notification button so that whatever that I post there, it will be the YouTube application on your phone will be able to notify you to say this channel has posted something. All right, thank you very much for watching. See you in the next lecture.